Getting started with Kubernetes and setting it up on AWS is quite easy. That is by using EKS, and you could use a command line utility which is EKS Cuttle to do that easily. And this is what we saw in the last video. But as you work on it, you need to set up more users and provide limited access to each of these users and different levels of access. So doing this is quite tricky, especially because there's not a lot of information available for this. So in this video, we're going to look into this specifically. So in this video, we'll first create a new IAM account, and then using this account, we'll create an EKS cluster. And next is we will see the differences between IAM permissions, because whenever we're using any of the AWS service, we would normally set up policies for users just to limit the amount of access those users have. But this is different when you work in Kubernetes, because Kubernetes uses a RBAC authentication and authorization system. So we'll look at that, at how it differs from IAM permissions. And next, we'll create some users. We'll create 4 types of users with different level of access. On the right is trainee, which would just have access to view pods and deployments and all. And then we'll have a developer who would be able to create the deployments. And then the developer would not be able to delete the deployments. And then we'll have an administrator, admin, who would be able to delete the deployments as well. And then we'll have a super admin who would have the master permissions. That means they could do anything on the cluster. They could create or delete the cluster as well, or modify the cluster as well. So a lot of these, most of these permissions are configured using AWS auth config map, which lives in EKS cluster. So we'll look at that. And then we'll add these specific permissions for each of these 4 users that we'll create. So let's get started. So first is log on to your AWS account. Go to IAM and users, add user. So we'll try to add multiple user. So for first is EKS cluster creator. So for these users, we don't want to provide management console access. We just want programmatic access so that they could use it just through command line. There is not much they need to do from the management console, because they can't see the pods and all in the management console. So we just want programmatic access so that they can use kubectl or some other tool to view the pods or deployments and all. So that's what we want. So next is permissions. So we'll create a new policy. So the policy would just provide access for EKS visualization, right? So we'll choose EKS service, and then we'll provide the list permissions and read permissions. If you see here, there is just described cluster, or things like Kubernetes access Kubernetes API, but there is nothing specific to deployments or pods or servers and all, right? It is just high level permissions, whether a user could talk to Kubernetes API, or whether user could list the clusters and all. There's nothing specific to Kubernetes resources here, and that's what is different. IAM permissions do not cover the specific resources for Kubernetes, and those we have to configure in Kubernetes. So I will for now add all resources, just so that it is all clusters and all, and I won't configure any request condition and all. So next we add the policy, no tag is needed. So new read policy. So we create this policy, and then here we had these users. So we try to find the policy, which was let's refresh. So here we have the policy. We go to next. No tags are needed for now. So we just add one manage policy, and we create these users. So I'll download the CSV file for these users. And so for for administrate, like for super admin and for like the creator, we need to add more permissions because they would be creating the cluster. So they need to have like more permissions, like cloud formation and all. So I'll just like to make it easy, like just for the EKS cluster creator and for super admin, I would provide administrator policy. So I go to policies. So this is admin access, which gives the full access. And then I say policy usage. So I would try to add 2 users, which is cluster creator and super admin, right? So I'm not attaching with admin, developer, or trainee. So attach these policies. So now let's create the cluster. So here I have my IDE. This is the terminal in my IDE. So I could just execute commands. So you need to have AWS CLI installed. So I'll just say AWS configure. This is basically, I would be using the creator account to create the EKS cluster. So this is the ID, and I'll just paste the secret now. Enter. So my user is configured. So I created a make file here. So this make file has a bunch of useful commands so that I don't have to type the full thing again. So the first we can just look at as AWS identity. So this tells which is the user that's logged in, right? So I say make AWS identity. So it says that EKS cluster, this is the user that I'm using right now. And to create a cluster, we have this command, which is EKS cluster, and this -f is the file name. So here is the cluster. Like again, you can look at the last video to go into details and all. So we have a couple of node groups that we create, and then this is the name of the cluster. So let's say make create cluster. So it's going to take like a few minutes. So I'll pause my video and then we'll resume after that. So the cluster is created now, as we could see. So like it started with creating like the subnets and all, and then it says like created the node groups and all, right? And here like it created the second node group and all, and so it says the cluster is ready. So now to be able to execute commands on Kubernetes cluster, we need to set the context. So again, for context, I have a command setting up of the context. I have a command here. So this is set context. Again, like I'll just use make set context, but the actual command that would be executed would be EKS util and write kubeconfig, and it says that this is the cluster, like the name of the cluster that we created, and it says this set kubeconfig context is equal to true. So it will just set the context also. So we say make we say set context. So it's going to set the context. So I'm using a local kubeconfig file, which is here. So my context is set here. So if I just try to say kube get all, so it says like by default the Kubernetes service is running. So it says that the Kubernetes service is running, and I'm able to point to the Kubernetes. So let's look at the difference between IAM permissions and the permissions which we define in Kubernetes. So IAM permissions is just used for the authentication part. Like to recognize a user, there are two things that are done. First is authentication, means what is the name of the user, and second is authorization, means what all can a user do. So the authentication part is done by IAM, which is AWS IAM, and the authorization part is done by Kubernetes. Like what all things can that user do in Kubernetes is defined by Kubernetes. That's why this is the service EKS, and the actions that we have available on the left on EKS is that we could see, like if we see the right, this is like just like encryption, like creating of add-ons or clusters and all, or node groups, but or like deleting of the cluster add-ons or some certain other actions and all, right? But these are not actions related to resources on Kubernetes. Like we don't see write permissions related to creation of the pods, creation of the deployments, or creation of the services and all, because those are done on the Kubernetes level. So on the Kubernetes, by default, like you could change the authorization model which Kubernetes use, but by default it comes with the RBAC authentication, like authorization model. So this is the default one, and in this you define roles and cluster roles. So cluster role is something that is available throughout the cluster, and role is specific that it's available within a particular namespace. So let's look at an example of cluster role. So to create a cluster role, you just define a YAML, just like you would do on defining a pod or defining a deployment and all. So first is like you declare the API version, which is like RBAC authorization and all. And then kind is cluster role. So I'll be defining cluster roles, which will be available. So we'll create this for each of those different users that we talked about. And then you provide name. What is the name of the cluster role? And API groups, these are the API groups that we use. And then within API groups, we have different resources, like it could be pods, it could be secrets, it could be config maps. And then we have verbs, that what are the verbs that are applicable, that are allowed for this cluster role. So once we define the role, so we say this is the role, and these are the resources to which it has access, and these are the things that could do on this resource, right, on these resources. So once we define this, we define a cluster role, like a role binding. So it could be a role binding is within like a namespace. Similarly, cluster role binding is defined for cluster roles. So if we look at this binding, cluster role binding, right, so we say in the metadata that this is the name and the subject, right? So if you are linking like the role of Kubernetes to a group in IAM, you'll just add a group here, right? But we'll do it for the user. So the kind for us would be user, and then we'll name that, which would be the name of the user. And then this is the reference to the role, right? So we say this binding maps to this user or a group here, and this is the role that it refers to, right? So we declare a role binding, cluster role binding here. So let's look at the example that we have and that we'll be doing for our code. So in role mappings, I've defined two types of role mappings. One is EKS trainee. So the trainee just has like read-only permissions, right? So we declare a cluster role, and the metadata, like name is trainee cluster role, and the API group is empty when we are declaring nodes, namespaces, and pods, right? And if you're doing anything in the apps, like which is deployments, daemon sets, stateful sets, replica sets, and all, they all go within the apps, right? So even for like nodes, namespaces, pods, we just allow that get in list is available for these resources. And similarly for all these deployments and all, we define the get in list is available. And other could be like for jobs and all, we again define get in list, right? So there is no write permissions for the trainee user that we create, like this is role we create, and now we bind the role to the trainee user, right? So here we see the cluster role binding, and we see the name is trainee cluster role binding, and the subject, as you see here, we are binding it just to a specific user, and this is the EKS trainee that we created. And then we just say that it refers to this cluster role, which is EKS trainee cluster role, right, which is the one which we declared above. So this YAML file, this is just a plain YAML file, and we need to create these roles and cluster bindings, and we need to apply them in the Kubernetes cluster. So let's try to do that. -f, and then we say role bindings and EKS trainee. So it says the trainee role created, cluster role created, and the trainee cluster role binding created. So just like we had the trainee user, like the trainee role, we have the developer role. So in the developer role, like for the nodes, namespaces, and the pods, we're just providing get and list. But we want to be able to create a deployment, right? So for creating a deployment, we add an extra verb, which is create. So a trainee will not be able to create a deployment, but a developer would be able to create a deployment, right? So this is the specific difference that we have. And because of this, developer would be able to create a deployment. And rest, like this was the role, and the role binding and all, it's in similar way. We'd say which user and what is the role. So now let's apply that. So there is one thing that is very specific to EKS and authorization is the AWS auth config map, which exists in Kubernetes systems namespace. So here I have a command which is which prints the config map, which is kubectl get config map AWS auth -n kube systems. So when you print this, you should be able to see the default config map. So the default config map that comes, so this maps the default user. So it says like this node instance roles and all. These are roles that are used by Kubernetes itself, right? But like there are no users that are right now mapped. So no other user except from the creator would be able to access Kubernetes. So we need to add more users here, or if we need to add more roles, and we need to, like if you're mapping roles to the users in IAM, so we'll add those to the map roles. So here I've exported the config map. So when you export it, it would look like, if you look, it would look something like this, right? And I could copy like these things, which is the groups, map groups. So this map users is like I've extended because I would be adding it for the EKS trainee. The stress trainee I could remove, and for a developer and EKS superadmin, right? So we say that this is the user and this is the username within Kubernetes that would be added. So from here, from this, Kubernetes says that this is the trainee that we have mapped, EKS trainee, and then from here it knows, okay, this is the roles and all that needs to apply for this EKS trainee. Same for EKS developer also. This EKS developer is mapped to the kind user. This is the subject here. And then like these specific permissions would be applied to this developer. And for system, like for basically superadmin, for superadmin, as I said, there are predefined groups that we have which are present in Kubernetes. So we just add the EKS superadmin to a group which is system masters, and then the username is wrong. It should be EKS superadmin, and this is the user that we created on IAM. So as you saw, we created like users here, like trainee, superadmin, developer, admin, and like the creator. We use the creator role like user to create, and then for these we have declared the mappings in AWS auth, and then we created cluster roles and cluster bindings. To go into details that how exactly everything is working, let's look at the context that is created. So we get this context like which defines like the clusters and all. So we'll just minify the cluster. So here, if we see, like this is the cluster that we created on US East 2, and this is the user, right? So the user that we had used was EKS cluster created, and then when we say use context, or like when we execute kubectl commands, right, it says user and then it tries to execute it. It tries to execute this command, which is AWS IAM authenticator, and passes this it passes these arguments. So we could also execute this command here, which is AWS IAM authenticator. So token -I, and then against this cluster, right? So we get like sort of a token here, and this token is then passed on to the Kubernetes, and this is which is explained here. So after we get this token is passed on the Kubernetes API server and into the authenticator / authenticator endpoint, right, via webhook configuration. You don't need to know this. I'm just covering so that you, if you want to know into details how exactly everything is done, you are able to relate, right? And then like, so basically that returns like a subject from the token, and once the subject is returned, so Kubernetes uses this map, which is AWS auth, based on the subject. It says that it was like, so the cluster, like the cluster creator is already present, but when you're adding new users, it will say, okay, this was the subject, which was EKS trainee. This is the AR and all. So from here, it knows that this is the IAM user, and this is the username, which was the subject. And from here, it tries to map like the cluster role binding and says what is the role, and see all the permissions corresponding to that role, right? It's a lot to go through in one go, but I will make a separate video for RBAC model, but I think this at least explains on a high level. You could just rewind the video and watch it once again to be able to grasp everything. So the link to all the code and everything would be down in the description below. And if you're liking the video so far, please give me a thumbs up and subscribe to my channel, because it motivates me a lot to create more such videos. So we had updated like the roles and all, and now we have modified the AWS auth config map, and we need to apply that also. So kubectl apply -f. So it says the config map is configured. So now we'll check out, like we'll configure AWS user as trainee, and then we'll try to create a deployment with that, and we'll see, we'll get an error, and then we'll try to do it with the developer. So I'll switch to the trainee user. This configure. And now when I say make AWS identity, right, so I get the identity is trainee. Again, like instead of the make command, you could all execute the same command, right, as it is. It's just shortcut for me. So you see that this is a trainee user, and the trainee user just had permissions for listing, right, listing of the deployments and all. So we'll try to get the deployments. Right now we don't have any deployments, so we can say cube so it says that no resources found in the default namespace, but it doesn't complain about any permissions and all. And we can also see other things like nodes and all also. So trainee is able to query the stuff, right? But the trainee does not have any create permissions. So if we try to add this deployment, which I have, so I have this deployment. If the trainee tries to add this deployment, he should get an error. So kubectl apply -f, and I say deployment. So you see here it says error from server forbidden, error creating deployment, right? It is forbidden. User EKS trainee cannot create resource deployments, right? So we can see that the trainee does not have permissions to create the deployments. And now we'll switch to developer, and we'll see that the developer is able to create the deployments. So let's use the developer now. So I again say AWS configure. And if we again send AWS identity, and should say that EKS developer is there, right? And if we look at the mappings for this user, right, so we look at the cluster role for the developer, it should be able to create like deployments or stateful sets or replica sets and all. So let's try to set the context, make. So there are two things, as you see. First, we are switching the user, which is the IAM user. Once the user has been switched, we set the context. And when we set the context, within the context, as you saw, the AWS IAM authenticator command is done, right? Which reads the AWS IAM user and then tries to get the token and send the token, right? So we need to be able to use that user, we need to set the context also. So if you say kubectl config get context, and we would see that EKS developer context would be used now. So this, we have a check here, this is the one that is used. And let's try to apply the deployment. So it says the deployment is configured, right? And let's say kubectl get pods. So we can get the pods, we can get the deployment, and so it is creating the cluster container and all. At the same time, now if we try to delete the deployment, we say kubectl -f, and then we try to say deployment. Now this user, like the developer, had the permissions to create the deployment, like create, but it didn't have permissions to delete the deployment, right? So the task for you would be, we didn't do it for the admin like we did for the trainee and the developer. We didn't do it for the admin, right? So create like a new role mappings for the admin where you copy these verbs and add a delete, and then you will see and then add that user to the AWS auth map, update the map and the role mappings and the role bindings and the role within Kubernetes by using the administrator user, right? Like the super admin, or by using like the creator, and then switch to the admin account and try to delete the deployment, and you would be able to delete that. So I'm logged in as cluster creator. So I would say make set context to just switch to the latest user, and then I'll try to apply the AWS auth map. So what I'm trying to show here is that I've commented out like the super admin user, and we'll use the super admin user, we'll try to update the node groups, and we'll get an error, and then we'll uncomment it. By uncommenting, we'll see that the user would be added to super like system masters group, and then the user will be able to modify the node groups and all also. So let's switch to the user, which is EKS super admin. So let's see, I'm logged in as super admin now. So it says like EKS super admin is the user that I have. Again, like the command that was executed was AWS STS get caller identity, and let's try to set the context. The context is set for that user, and then try to delete the node groups. So already have a command for deleting the node group also. So the command that I have is here, which is EKS delete kubectl delete node group. This is the cluster, and this is the name of the node group. And if we look at the cluster, so I had already defined that this was the second node group that I want to create, and it should have two nodes already there. So, and in fact, like this user should not be able to, since it should not have any permissions, it should not be able to see the node also. So you see, it is unauthorized, the system admin. So for sure, like it would not be able to delete. So when we say EKS kubectl, so if you recall, if we look at the IAM permissions, this user has the administrator permissions. So if we look at the super admin user, this has the administrator access, means like this has the full access. But even if they have the full access, that does not give them permissions to objects in Kubernetes, because that is managed by Kubernetes RBAC. So let's now switch back to our creator user, and we'll update the config map, like this map, which will add this EKS superadmin to the system's master, and then we'll be able to delete the node group also. So I switch to the creator role, and I would say make set context, and just to verify, make AWS identity, because I'm just switching to a lot of users. It is difficult to make sure that the right user is logged in. So we see that the right user is there, and now we'll apply the latest config map, which has the superadmin commented out. That means it would be added to systems master groups. So we didn't add it. This was this is predefined group by Kubernetes. And let's switch back to the system admin and try to delete the node groups. So AWS, it's superadmin, and make set context, updating the context, and say make delete node group, which would do this command, which is EKS delete node group, and with the name is ng2 is the node group. So now if you see, it is executing, it's trying to delete the node group. So we see that the node group is deleted. So let's try to recap everything, because there was a lot of things that were going on. So we first created the IAM account and the cluster using the creator user. And then we saw what are the differences between IAM permissions and Kubernetes RBAC permissions. We saw, like for the superadmin had administrator access in IAM, but still he was not able to list the nodes or like anything because the permissions were not mapped, right? So IAM permissions just lets Kubernetes know that who the user is. Now what the user could do within Kubernetes is defined within the RBAC permissions, that is using the cluster roles and cluster role bindings, or roles or role bindings for a specific namespace, right? So we saw the RBAC versus IAM permissions. And then we added like different users to see what permissions they could do. Again, starting from the right, trainee was just able to list the deployments. Developer was able to add the deployment, but it was not able to delete. And the exercise for you is to add an admin, which is able to delete the deployment as well. And then superadmin, earlier it didn't have any permissions because we didn't configure it in the RBAC or AWS auth map. And then when we configure it, it was able to delete the nodes as well. And so we talked about AWS auth config map. So by default, we would have AWS auth config map. And if we look at the AWS documentation, which is important. So here it says when you create AWS EKS cluster, the IAM identity user or role such as federated user that creates the cluster is automatically granted the system's master permission in the cluster's RBAC configuration in the control plane, right? This IAM entity does not appear in the config map or any visible configurations. So make sure to keep a record of which IAM entity originally created the cluster. And it also talks about that you need to use the AWS config map. So we added the AWS auth config map, and then we added permissions for specific user for each user by adding the cluster roles and cluster role bindings and mapping them to users that we declare in AWS auth config map. So let's look at the AWS auth config map and the cluster role bindings once again, just to make sure we have everything revised. So here we have the AWS auth map, and by default there was nothing in the map users. This was done by Kubernetes itself, like this was done by EKS by itself. And then we mapped for each user, like EKS trainee, we created roles, like this is a trainee cluster role. Then we create the role binding and we say that we are mapping to this user and this is the name, right? So again, like the kind could be user or the kind could be group also if you're mapping the groups. So I hope you now understand that how exactly like permissions works for EKS within AWS. So if you like this video, please give me a thumbs up and subscribe to my channel, and also in the comments below give your feedback so that I can improve on my videos and make better videos. Thank you.